Okay, we're going to now take a look at the homework assignment for 2.1. Let's see here, get this thing zoomed in a little bit. Okay, find the slope of the tangent line to the parabola at the point 1, 5. So remember here that we're saying that our x is 1 and our y is 5. And then here is our actual function. We could rewrite the y here as f of x. So the slope of the tangent line is equal to the limit as x approaches whatever x value we're going to. In this case, it's 1 of f of x. Now, the function itself is 6x. Oh, sorry. Oh, man, that got zoomed in again. Okay, sorry. Let me write out definition of f of x minus f of 1 over x minus 1. So that's what we need to figure out. So this will be equal to the limit as x approaches 1 of f of x, which is 6x minus x squared, minus f of 1. So what do we get when we plug 1 in here? We get 6 times 1 minus 1 squared. That's just going to be 5. Now we could have seen that right here, that, you know, when we plug in 1, we get 5. But I'll just show you that you can evaluate it. And then this is all over x minus 1. Now that's equal to, if we were to take the limit right now, we'd still get 0 over 0. If you try and plug in, we would get the form 0 over 0 if we tried the limit. So when you do some algebra here, what I'm going to do is take that numerator, I'm going to rearrange it, negative x squared plus 6x minus 5 over x minus 1. I notice that the numerator is a quadratic. It's a trinomial. I'm going to try and factor it. So limit x approaches 1. Might be worth it for me to factor a negative 1 out of the top. Might make it a little bit easier for me to factor. And then depending on your techniques of factoring, how comfortable you are with them, we would get limit x approaches 1. Got the negative 1 on the outside. Let's see. That factors to be x minus 3 times x minus 1 all over x minus 1. So just, you could double check. I'm sorry, I said x minus 5 times x minus 1. Double check this here. X squared, we get minus 1x minus 5x plus 5. So that does work. And notice here that the x minus 1's cancel. So all you're left with is the limit as x approaches 1 of negative 1 times x minus 5. If I now let x become 1, we get 1 minus 5, which is going to give me negative 4. But then I multiply it times negative 1, so I get 4. So the slope of the tangent line here should be 4. Now it wants the equation of the tangent line. So remember that whenever we're in part B, whenever we're trying to find the equation of a tangent line, what we do is we use this formula, y minus y1 equals m times x minus x1. Here we know what y1 is. It's x1 and y1 is just a point on our graph, the point on the graph. So that's going to be the 1, 5. So we go y minus 5 equals the slope, which we just found to be 4, times x minus x1, which is 1. And then I can say this y minus 5 equals 4x minus 4, distributing the 4. Add 5 to both sides. We get 4x plus 1. So there's the equation of our line. Now, for part C, we want to graph the parabola and the tangent line. So for graphing the parabola was y equals 6x minus x squared. One way you could do this, you could find the x-intercepts first, so you could set it equal to 0. You could factor out an x, set each of the factors to 0, and that would give you x is 0 is 1 x-intercept. The other one is x is 6. And we know that this parabola opens down because this opens up. Because we have a negative in front of the x squared. You could also find the vertex. Let's see if these graphs, which ones we can eliminate here. We can eliminate this one for sure. And then when we go to graph our line, remember our line, when we graph this, so we graph this, has a y-intercept of 1 that comes from this, and it has a slope of 4. So up 4, 1, 2, 3, 4, and over 1. So we'd have a line that looks like this. So it could be this one. Couldn't be this one. And let's look down here. Can't be this one. That's a flat line. So it looks like this. Looks like they're counting by 2s here. 2, 4, 6, 8, 10. So this looks like the one. All right. Now let's see. We want to see the solution here. There it is. Okay. So now let's take a look at number 2. So consider the curve here. So it's the same sort of problem. We want to find the limit x approaches a, or x approaches 1, right? So this will set up exactly like the other one does. The curve that you get will be a cubic function. So you'll be able to determine what it looks like. So I don't think I'll work through this one because it's the exact same setup. So I'm going to just bypass that. Okay, find the equation of the tangent line to this curve. I guess I'll work through this one. All we want is the equation, all right? So we don't have to do graphs or anything like that. First of all, remembering I have 2 and 4 here, what I want is the slope of the tangent line will be the limit, this time as x approaches 2, of f of x, which was x cubed minus 3x plus 2, minus f of 2. Now, of course, if you plug 2 into this, we should get 4. So this should be 4, and then all over x minus 2. So what happens here is we get limit x approaches 2 of x cubed minus 3x minus 2, because you do 2 minus 4, all over x minus 2. And now we run into a little bit of a problem because the numerator has 3 terms, but it's not quadratic, it's cubic. So the question is, how can we factor it so that we can get this x minus 2 to cancel? That's kind of the key to this whole thing. We know we want this to cancel. So we're hoping it divides into this. So what I'm going to do is I'm going to use, I can use long division or synthetic division. I guess I'll use long division because it's more powerful. With long division, what we do is we take the top, x cubed minus, now we don't have an x squared, so we need to put a space here for x squared, and then minus 3x, and then minus 2. And then on the outside, we're going to divide by x minus 2. So we ask ourselves, what do we have to multiply x by to get x cubed? Again, this is long division, so if you need to go back and review long division, you can. To multiply x by something to get x cubed, I need to multiply by x squared. And then what I do is I multiply x times x squared, that's x cubed, I put it here. And I multiply x squared times negative 2. I get negative 2x squared. I line it up underneath the x squareds. Come through, change the signs. Subtracting basically changes the signs. And then go ahead and go down with this. These two cancel. Nothing, 0x squared plus 2x squared is 2x squared. Negative 3x, and then this is really like a 0, so adding nothing to it gives us negative 3x. And then over here, adding nothing to negative 2, we get negative 2. So now we ask ourselves the same thing. What do I multiply x by this time to get 2x squared? So I need to multiply by a 2x. Then I multiply 2x times x, I get 2x squared. I multiply 2x times negative 2, I get negative 4x. I come through, I change the signs. This is minus, this becomes plus. I go ahead and I go straight down with this. Negative 3x plus 4x is x. And then just bring the negative 2 down. And then what do you have to multiply x by here to get x? And so we have to multiply by 1. Distribute the 1 through, we get x here. Distribute the 1 to negative 2, we get negative 2. Come through, change the signs. Add down, we get a remainder of 0. And that's a great thing, because it means that this limit right here turns into limit x approaches 2. When I divide these using long division, all I get is this piece right here. So I get x squared plus 2x plus 1. And now I just let x go to 2. So if x is 2, this is a 4. And then here, plus 4, and then plus 1. This is 9. So the slope of my tangent line is 9. And then I'm going to use my formula y minus y1 equals m times x minus x1 to get my equation. So y minus 4 equals the slope I just got, x minus 2. Let's distribute through here, 9x minus 18. Let's add 4 to both sides. And you should get 9x minus 14. And we will check that real quick. Curious to see if the book did the same way or if they did synthetic division. They use the other definition. Okay, well this is worth looking at. They use the other definition for the slope of the tangent line. And by using the other definition, when they work this out, everything goes away. They get an h to come out right away, and then it cancels. So two different approaches to the same problem, you get the same result. So I'll leave that there for a second so you can look at it. So remember, on the definition of the tangent line, there's two different really approaches to it, two different formulas. And so depending on which one you use, it will dictate, how easy or hard it is. There's no like rule of thumb that you can use, unfortunately, that will always work, or it will tell you which way is better. You just have to kind of try one. If it doesn't look good, go to the other one. All right, find the equation of tangent line and the curve at this point. So let me do this one using the other definition. So here's what I'm using. The slope, got to keep remembering to use my smaller pen there. Slope tangent line could be limit h approaches 0, f of c plus h, or a plus h, sorry, minus f of a over h. That's one way to do it. That'll give you the slope of the tangent line at x equals a. The other approach is the one I was using before, limit x approaches a, f of x minus f of a over x minus a. So those are the two definitions I can use. I've been using this one in my examples, so I'll use this one right now. So here's our function over here, f of x equals square root of x. So let me go ahead and, good, I've got some room here. Slope of tangent line is equal to the limit h approaches 0 of f of a plus h. Now remember, a in the problem is 81. So what happens if I plug in 81? Well, I'll write it out. F of 81 plus h minus f of 81 all over h. Okay, this is equal to the limit h approaches 0. Okay, what happens when I plug in 81 plus h into the function? I get square root 81 plus h. Then minus over here, plugging 81 into the function, I have square root of 81, which is 9, all over h. Now, if we try and let h go to 0 right now, we will get 0 over 0. So I need to do some algebra. And since I see a square root, two terms, I'm going to come in with conjugate, top and bottom. And then when I go through on the top with that conjugate, multiply through and FOIL out, the first multiplication, the roots go away. I'm left with 81 plus h. The middle terms will cancel, so I just have to look at that last one, which is going to be negative 81 all over h times that conjugate that I had introduced. And on the top, the 81s cancel, and all you're left with is an h. And that's important because the h up here will cancel with the h down there. I'm left with a 1 up here. So here's where I am. Limit h approaches 0 of 1 over square root 81 plus h plus 9. Now I actually let h go to 0. When h goes to 0, this term will go away, and we'll be left with 1 over, notice I'm not writing the limit anymore, square root of 81 plus 9. But square root of 81 is 9, so 9 plus 9, and so I get 1/18. So that's the slope of my tangent line. Now I need to find the equation. So I'm using my y minus y1, here in this case is 9, equals the slope m, 1 over 18, times x minus x1, or x1, which is 81. And then I can go ahead and distribute through. So I get 1/18 x minus, let's see, 9 halves. Let's see, I get 81 divided by 18. 9 goes into 81 9 times, and 9 goes into 18 twice. So I get 9 halves. And now I need to add 9 to both sides. 1/18 x minus 9 halves, and then plus 9. I'm going to rewrite 9 as 9 over 1. And then I'm going to multiply top and bottom by 2, which will actually give me 18 over 2. I'm getting common denominators, so I can put these two together. And so I get y equals 1/18 x, and then plus 9 halves. That should be the equation of my tangent line. So we'll take a look at that. And look at, in this one, they use the other definition, figures, right? Well, we get the same result, again, so you can see. I'll leave that there for a second so you can see how they did it this way. They still had to do the conjugate, so it just, the algebra works out a little bit different. Okay. Real quick, I've got to do a pause. Okay, let me get back to this here. All right, where are we here? All right, find the slope m of the tangent to the curve. I'm going to give you a curve there at the point x equals a. So what we want here is to find a general tangent, slope of a tangent line. So what we're going to do is we're not going to use a specific number, and we get to choose which definition we want to use at this point. Okay, so let me take a stab at the definition that I'm going to use here. We have to pick one of them. So let me use the one with h approaches 0. Let's try that one. So what I want to do is figure out what this limit is. Now, I'm just going to say equals. Limit h approaches 0. So I need to know what f of a plus h is. So what would happen if I take a plus h and plug it in for that x and that x right there? We would get 5 plus 5 times a plus h squared minus 2 times a plus h cubed, and then minus, now this is important, f of a. Now f of a is what I get when I plug a in for x, and I'm subtracting the whole thing, so I'm going to have 5 plus 5a squared minus 2a cubed all over h. Now, when I look at this, I realize that I'm going to have to square a plus h, and then I'm going to have to distribute through with a 5, and then I'm going to have to cube a plus h, and then distribute through with the -2. Just to show you the contrast, let's look at the other definition. Let's see if that one looks any better for us to use. The other definition would say that we need to find the limit as x approaches a of f of x minus f of a all over x minus a. In this case, we would have limit x approaches a. Now f of x is just what we have up there with x's in it, which it already has. Then subtract from that f of a, which is everything we have, replacing the x's with a's instead, and then all over x minus a. Now, the advantage to this one here is that I don't have to do any of these expansions. The bad news is that the factoring of this might be tough. So we kind of have to make